Okay, precipitation reactions. Precipitation, if you think of rain, rain is a form of precipitation, and what it means is something falling. So when you mix two solutions, so two dissolved things together, and they produce a solid, that solid is going to fall. So a solid is produced, you pour something in, and a solid is produced, that means little grains, and those are all going to fall to the bottom and settle down there. So they precipitate down. That's why these are called precipitation reactions. And all precipitation reactions are metathesis reactions that produce a solid. So it has to be a solid produced. If there's no solid, it's not a precipitation reaction. When these take place, you have two solutions, which means two aqueous ionic compounds that are dissolved in water. And so you'll just have two completely separate solutions. And then both of them will be aqueous of some kind of ionic compound. That means you have a cation and an anion. When you mix them together, so pour them both into the same beaker or same container, they partner swap, and one of those new partners is a solid, and the other one will remain aqueous. So the two things, when they partner swap, one will be a solid and one will be an aqueous compound. If you do not form a precipitate, if both of them stay aqueous, so no solid is formed, that means no reaction happened. A solid has to be produced in a precipitation reaction, in a double displacement reaction, in a metathesis reaction, all the same thing, in order to have a reaction actually occur. No precipitate, no solid form falling to the bottom, there is absolutely no reaction. And you don't have to do a reaction every single time to figure out whether or not a solid will form. If you see one, then a reaction occurs. You can actually look at the reactants and the products that are formed to decide whether or not a solid is formed. There are certain rules that you can use to tell whether or not an ionic compound will dissolve, so whether it will be aqueous, or whether it will be a precipitate, so it will not dissolve. And we'll go through those rules later on this unit. We'll actually do a lab later on this week in which we will figure out what those rules are, and come up with our own descriptions of how we can figure out whether or not a compound is solid or aqueous. But before we go ahead and talk about solubility rules, first we'll talk about metathesis reactions. So they're just double displacement reactions, which we did in full force first semester. Now we're going to talk about them again, just to kind of refresh ourselves, but we'll also give it a new spin when we take a look at whether or not a solid is formed and whether or not a reaction actually occurs. So let's do this first one with potassium iodide reacting with lead 2 nitrate, and we're going to see what it forms. So first off, let's take a look at those individual compounds. So Ki, which we say is aqueous, that means we took solid potassium iodide and we put it inside of water. When we did that, it became aqueous, which means it dissolved. And so when things dissolve, when ionic compounds dissolve, they actually ionize. So that Ki, when it's in the water, it's not Ki anymore. It's actually K+, so potassium ion, and then I-, so an iodine anion. So ionic compounds, when they dissolve, they break apart. We call this ionization. Ionization, not just dissolving, they ionize in solution, so they break apart into their individual ions. Lead nitrate then, lead 2 nitrate, PbNO3, 2. That's also an ionic compound. It is also soluble, so when we put it in water, if we take solid of that and we put it in water, it doesn't just dissolve, it doesn't just disappear from our eyes, it turns into Pb 2+ and 2 NO3 minuses. And notice how that one is balanced. I wrote a 2 in front of the NO3 because over here in the solid version, there is 2 NO3s. And so when it ionizes into Pb2+ and 2 nitrates. Right, so this is what the AQ right down there means. It means that the Ki, it is ionized, and the PbNO3, it is ionized. So inside of the solution, really, when we mix those two guys together, we're going to have Ki aqueous, and we are going to have PbNO3 aqueous. But even though we call this Ki and we call this PbNO3, there is no Ki and there is no PbNO3 inside either one of these. Instead, inside of this first solution, it is K pluses and I minuses. There's no Ki, just K pluses and I minuses. We write it as Ki because it's easier, and we put the AQ next to it to indicate to the reader, hey, really what's in here is K plus and I minus. The lead nitrate, it's not PbNO3 it's Pb2 plus and NO3 minuses inside of that solution. Once again, we write it as PbNO3 2AQ to indicate to the reader that they are separated. But really inside there isn't any individual or combined ions. They're all separate from each other. So what that means is when we write this reaction right there, that's not actually what's occurring. There's not Ki's together combining with PbNO3s that are together. Really what's happening is we're mixing K plus I minus plus Pb2 plus 2 NO3 minuses. And that's what's reacting. So this side, so that is what's in the solution. That's what's actually combined. That's what's going to react. Now is where the partner swapping begins. So let's take a look at what's going to happen here. So originally this K was with this I when it was a solid, and that Pb was with those two NO3s when it was a solid. But now they're all mixed together, so we're going to give them the opportunity to find love in different ways. So instead of K plus going with I minus, let's find it a new anion to pair with. And what better anion to pair with than NO3 minus? And Pb2 plus, no longer is it going to be with nitrate. Let's try and tag it up with iodide. So when we write these formulas, let's also keep in mind what is aqueous and what is solid. So PbI2 is actually a solid. Okay, so that is a solid compound. That would be our precipitate in this reaction, which means it is going to form into a solid, it is going to precipitate, fall to the bottom, and that's going to make this an actual precipitation reaction. How do I know that? How do I know that PbI2 is a solid? Well, not only because I'm brilliant, but also because I know my solubility rules. And you too will know your solubility rules in a couple of days so that you can figure out whether a solid's formed or whether no reaction happens. Now, the K plus and NO3, the potassium nitrate that we could also form, that is aqueous, which means it doesn't form a solid, it stays an aqueous compound. So remember, we always form one solid, one aqueous compound. KNO3, that would be our aqueous compound. So we've got our solid, we've got our aqueous compound. Lead iodide is a solid, potassium nitrate is aqueous. But wait a minute, this aqueous guy right here, that AQ, remember AQ means it's ionized. That means it's not KNO3. It is instead K plus NO3 minus. It's aqueous, which means it's ionized, which means it's not KNO3, it's K plus and NO3 separate entities. So what I want you guys to see here then is check out potassium on the reactant side. Potassium on the reactant side was K plus. Potassium on the product side was K plus. Nitrate on the reactant side was NO3 minus. Nitrate on the product side is NO3 minus as well. My question is to you, did potassium change from the reactant side to the product side? It was K plus here and it's K plus over there, which means it did not change. That means it didn't react. And so we can actually say, hey, potassium, since you didn't change, you're not really part of this reaction. Nitrate, it was NO3 on the reactant side, it's NO3 on the product side. That means it didn't react, it didn't change, so we can ignore it as well. What we would say then is that the only thing that reacted when we combined these two was Pb2 plus reacted with I minus, and they formed PbI2. The potassium, the nitrate, since they didn't change, they're in there, but they're just spectators. They don't change, they're not part of the overall reaction. This right here, the Pb2 plus I minus, that is what's called the net Ionic Equation. Net means what actually occurred. So here, overall, this is the reaction that legitimately occurred. And we need to balance this, so let's put a 2 right there in front of the I to represent the two I's that need to react with the Pb2 plus. The K plus and NO3, they didn't change, and so we call them the Spectator Ions. Not saying they're not there, not saying they don't exist. They do exist, Okay, but they just don't play a role in the reaction because they themselves are not chemically changing. So why write them in? This right here, when I ask you for the net ionic equation, that's what I'm looking for. It shows just what reacted. When I ask you for the double displacement reaction, what I'm looking for there would be what we would write back in Gen Chem days. So Ki plus PbNO3, 2 turning into KNO3 plus PbI2, and just balancing that, of course, with 2 there and a 2 there. So that would be the full equation, or the double displacement reaction, or the precipitation reaction, if we wrote solid right there. This one right here, though, would be our net ionic equation, which just shows the reaction, and those two would be our spectator ions. All right, we're going to take a look at one more example to see this kind of metathesis and the precipitation reactions and whether or not a reaction occurs. Take a look at the net ionic equation. So first off, there's actually a typo on here. This NH4NO3 that we see right there, that should actually be NH4Cl. I just now noticed that. So our reaction here is going to be NaNO3 plus NH4Cl. We're going to see what they form. Now, since both of these are aqueous, that means when this reaction occurs, or before this reaction occurs, when we set this up, we would have two solutions. One of them would have NaNO3 aqueous, so remember that's not NaNO3 in all actuality, it's Na plus and NO3 minus. So they're separate things floating around the solution independent of one another. The NH4Cl, that's not NH4Cl, it's NH4 plus and Cl minus. So they're separate entities. They've ionized in the solution, so they've broken apart into cation, anion. We'll take both of those, combine them together into one solution, and we're going to see what occurs, if anything. So first thing, let's break these apart into ions. Let's show the full ionic equation, what's actually happening. So we are combining Na plus and NO3 minus from the first beaker. We're combining that with ammonium, NH4 plus Cl minus from the second beaker. And those are going to mix up, they're going to partner swap, and we're going to see if a new solid forms. So Na, that is our original cation that went with nitrate when it was a solid. We've dissolved them separately. It's going to try and recombine with Cl minus. Ammonium was going to try and recombine with NO3. So NaCl, that is sodium chloride, and that is aqueous. NH4NO3, the other partner swap possibility, NH4NO3 is also aqueous. So let's rewrite those. Since they're both aqueous, let's write them as they actually are, because NaCl, if that was in a beaker, wouldn't be NaCl, it would be Na plus Cl minus. NH4NO3, that would be NH4 and NO3. Okay, they're not going to make solids. So that means on the reactant side, we would have Na plus and Cl minus, and we would have NH4 plus and NO3 minus. So let's see what actually changed. So sodium was Na plus, and over on this side, Na plus. Okay, so that guy didn't change. Let's go ahead and cross him out. The nitrate, okay, it was NO3 on this side, and it's still NO3 minus on that side, so he didn't change. Let's cross him out. What about the ammonium? Okay, there we go. So NH4 plus, it's still NH4 plus on that side, so we're going to have to cancel him out. And then Cl minus, okay, here we go. So Cl minus, it's still Cl minus. Everything's crossed out. This can't be right. But it is right. So what happens here then is no reaction. Since we combine those, they form aqueous. That means nobody changes. They all stay ionized. So that means when we combine sodium nitrate and ammonium chloride, no precipitate forms. That means no reaction occurs. Everybody stays exactly the same as they were to begin with. That means when we mix those two solutions together, what's going to be inside of that beaker at the end is Na plus, NH4 plus, Cl minus, and NO3 minus. The same 4 things that were in the original beakers are going to be in the beakers at the end. No chemical reaction happens because nothing chemically changed. That's why there is no reaction for this guy. And so the net ionic equation would just be no reaction. So nothing occurred. Everything is a spectator. No solids formed. So if we were to do this reaction in class, what we could derive from that then is that sodium chloride is always soluble in water and ammonium nitrate is always soluble in water since no reaction occurred. And we're going to do a lab that we're going to combine different ionic compounds, different soluble compounds, in order to figure out whether or not they form a precipitate and use the fact of whether or not they make a precipitate to figure out those solubility rules. So I can look at this reaction and I can say NaCl, always soluble, not going to make a solid. Ammonium nitrate, always soluble, not going to make a compound. I can do that because I know the solubility rules, and you're going to learn the solubility rules in the lab we're going to do. So here is a copy or a picture of the lab that we're going to be doing in class. You guys should have a copy of this. What we're going to be doing is we're going to set up little spot plates. They look just like this setup right here. And we're going to be combining 2 aqueous compounds to see whether or not a solid forms. So the example that they have filled in, what they did was they combined barium chloride with silver nitrate. And it's just an X and Y setup like that. So right here in this one, we'd be combining BaCl2 and Na2CO3. So barium chloride and sodium carbonate. We would see whether or not a precipitate forms, and that's going to tell us what kind of compounds are soluble or insoluble. And what you can see, what they did right here, is when they combined those 2, they saw the white precipitate, so they wrote that in there. And the 2 compounds that are formed are going to be barium nitrate and silver chloride. So the reason they know that it's barium nitrate and silver chloride is because they combined AgNO3 and BaCl2, and that's going to form, so a partner swap. That means the Ag would go with the Cl, and the Ba would go with the NO3. And you got to balance charges, of course, so it'd be BaNO3 2 and AgCl. So those are the 2 compounds that are formed. We can see, or what they saw, and what you're going to see is that a white precipitate was formed. That means one of these 2 was solid. The question is, who was the solid? One of those was solid, one of them was still aqueous. When we go through and we'll do some different experiments, we can use the process of elimination to figure out who was solid, who made that white precipitate, who stayed aqueous. And at the end, we can then figure out what kind of compounds are always soluble and what kind of compounds are always insoluble. So what you're going to be doing then for your homework, what you want to have finished before you begin the lab, so the sooner you get this done the better, is go through and fill in who all of the possible products are for these double displacement reactions. So for example, let's do this circle right here together. So for that one, we're going to be combining sodium carbonate with silver nitrate. So that means Na2CO3 plus AgNO3. And for these, we're not going to be writing the net ionic equation. We're going to be writing the full double displacement. So Na2, that's Na plus, is going to recombine with NO3. So one possible product is going to be NaNO3. And then silver can combine with carbonate. And so that's going to be Ag2CO3. So inside of that little circle up there, we're going to put NaNO3 and Ag2CO3. Kind of a tight space, so try and put them in there the best you can. And then leave yourself some room down here on the bottom, because when you combine those in class, you're going to write whether precipitate formed and what it looked like. So if you put these together and no precipitate forms, you would write inside that circle NR to indicate no reaction. And what that would tell you is that sodium nitrate and silver carbonate are both soluble. And so you can write that into your solubility rules. If a precipitate forms, you would write down what color the precipitate is. And PPT, that just indicates precipitate. And that's going to tell you one of those 2 is a precipitate. And we'll do other experiments so you can figure out which one of those 2 is a precipitate. So that's it. We're going to spend a day or two doing this lab. We're going to figure out the solubility rules, and you're going to be so much cooler as a result. That means next time you're walking down the street and someone says, gosh, silver carbonate, I wish I knew if that was a solid or not, whether or not it was soluble in water. You're going to be able to say, silver carbonate, it is actually fill in the blank. You'll learn.